Thanks. Thanks so much, Alan. And again, welcome to the session. Apologize for the technical difficulties, but you're in strategies for connecting thousands of factory assets. My name is Craig Resnick with the ARC Advisory Group. We're going to be kicking the presentation off with my presentation to give an introduction to the topic. Then from there, what we're going to do is we have four great speakers today. We have Peter Lutz from the OPC Foundation. We have Andreas Foth from VDMA. We have Terry Deneau from Renault and Dr. Julian Backhouse from BMW. And I would say, Alan, once we're ready to go, we'll start off with my presentation. And then from there, we'll go to hear our four speakers and then go to our panel session. We'll be joined by Eric Bonstead from Microsoft, from Azure, and Charlie Sheridan from Google. So without further ado, Alan, let me start my presentation. Hi, this is Craig Resnick from the ARC Advisory Group. I want to welcome you today to our session on strategies for connecting thousands of factory assets. And we're all on this digital transformation journey. And ultimately, there is no digital transformation journey if you don't have all your people and processes and machines connected. The question becomes is what are the tool solutions that really can help companies do that? Companies are always trying to say, how do I either begin my digital transformation journey or how do I continue to progress it? Are there organizations that I can work with that can help me with connectivity, either using industry standards or organizations that help with the digital transformation process? But the challenges we all have are sometimes things don't go according to plan. We have certain things that occur, whether it be pandemics or just even economic cycles, economic headwinds. So companies are always looking for ways as how do they continue to adapt that latest technology, but knowing that there may be some headwinds in the marketplace that sometimes make it a little bit more difficult to obtain and get justification for that technology. But the only thing we can certainly say is that if you don't have asset connectivity and digital transformation, no company, regardless of what industry you're in, what you produce, is going to be able to have the flexibility and the agility to kind of keep that competitive advantage in this flat world, but also this post-pandemic new normal that we're all moving towards. So as we talked about how essential asset connectivity is to digital transformation. And we're all very familiar with industrial Internet of Things and Industry 4.0. And, this is a way of, these technologies of being able to use low-cost sensors to be able to measure and to record the behavior of assets. This tells us this behavior, and it helps us certainly with things like, proactive maintenance, predictive maintenance, the ability to kind of reduce unscheduled downtime, the ability to increase productivity, whether it be different KPIs or metrics such as overall equipment effectiveness, and kind of increasing, of course, the overall value of the organization and the operation. So everybody's really been affected by either Industry 4.0 or IoT implementation. And again, you cannot move forward with digital transformation without having that level of connectivity down to the least expensive sensor, because you don't want to have the weakest link in the chain would be something that's just not connected and not providing information. So you've got to make sure you can have that connectivity to things. And even in a situation where sometimes you have assets on the factory floor that are old and need to have low-cost sensors installed and be able to have that IoT connection so it can participate in the whole digital transformation of the organization without having to do a full rip and replace. So you've got to have those, your production lines and machines and equipment, connected. And because to really get that organizational value, but because of the multiple generations of equipment on the factory floor, it's not easy to have this seamless connectivity across all the different production domains, right from the sensor level all the way up through above the control system and into enterprise computing. So ultimately, our goal is, and on a very, very busy chart here, is to see that all fixed assets, all mobile assets, all human assets that everything is connected, whether it be a hardwire connection on, through Ethernet, for example, whether it be a Wi-Fi connection, whether it be a cellular connection, whether it be 5G or even even lesser technologies like 4G. But the idea is everything must be connected. You can't collaborate if you're not connected. You can't get the latest information if you're not connected. You can't get what we call at ARC as the single version of the truth if all your assets are not connected. So the idea is that every, again, fixed asset, mobile asset, human asset, machine, the common denominator is everything must be connected truly to achieve the digital transformation that's required to survive in this world. And it's not like connectivity is new. I mean, there are certainly, proprietary network connections that go back to the 1970s and 1980s, for example. And you certainly began to see standards like OPC appear in about 1996. But as these things continue to evolve, is what are the latest is regarding standards and connectivity tools and processes to kind of help companies connect those multiple generations of assets on the factory floor. So we put together a really exciting group of speakers today at this at our session, coming from automotive manufacturers, standard organizations, and engineering organizations. We're going to be able to present you some case studies and solutions that have helped. And in this case, we're leading more so on the discrete side, but to be able to give you that industrial interoperability that's required to really complete your digital transformation journey, provide you the business value that you're looking for, and most important, especially today, is be able to provide the manufacturers with the operational resilience to be able to not only survive, but thrive in this post-pandemic world. So with that, I can't wait to listen to our speakers now. And again, this is Craig Resnick with the ARC Advisory Group. Thank you so much. Have a great day, and looking forward to our session.
Hello and welcome to my presentation about how OPC contributes to the digital transformation for discrete industries. My name is Peter Lutz. I'm the responsible director for the field level communications initiative of the OPC Foundation. The vision of the OPC Foundation is to provide an open, unified, standards-based IIoT communication solution that covers all the different use cases that you can see here as part of the interaction model. The FLC initiative is extending the existing OPC framework, which is an IEC standard, to address all the different requirements out of factory automation and process automation, and is therefore specifying extensions for field exchange. By using OPC UA as a unified and standardized communication solution from field to cloud, and certainly also in the opposite direction, information is made available and made accessible in a secure but also in an extremely flexible way, which is supporting the convergence of IT and OT. And if we compare this approach with the traditional automation pyramid, it becomes clear that we change the rather strict leveling or layering that we had in the past and even today with a much more flexible and harmonized communication solution. When we talk about industrial interoperability, I think it's clear that we need to have standardization on different layers if we look into the ISO OC layer model. On the one hand side, we need standardized network access. In addition, we need to have standardized communication protocols But furthermore, we also need standardized information models and common semantics to provide information in a vendor-independent way. The solution approach of the OPC Foundation is combining well-established standards such as IEEE 802.1, 802.3, the Ethernet standards, with additional protocols out of IETF, and then adds common information models and extensions for field exchange, plus common semantics for the various device types and applications. So we have then a standardization on all the levels, which is then providing industrial interoperability. The technical solution for the extensions for field exchange are developed by more than 300 technical experts from more than 60 member companies of the OPC Foundation. In addition, 27 companies have joined the so-called steering committee of the initiative to give additional financial contributions, to provide manpower, and to bring in their expertise out of industrial automation and industrial communication. And if you look through the list of companies that are represented, you find all the major automation suppliers in the world that are active in process automation or in factory automation, or that even cover both domains. A key technology to meet the specific requirements of industrial automation is Ethernet TSN. TSN standing for time-sensitive networking. This technology is not only critically important to support real-time communication, but also to drive the convergence of IT and OT protocols, allowing that different protocols share the same network infrastructure using commercial off-the-shelf hardware components. In this context, it's also important that the OPC Foundation is aligned with the activities of IEC IEEE 60802 that develops a TSN profile for industrial automation. This slide is explaining the overall technical approach. First of all, the solution is being based on existing OPC UA technology with the different communication services, client server on the one hand side, and the extensions for publish, subscribe on the other hand side. Also using the integrated security features and the base models. The FLC technical working groups are specifying a base model for automation components with the possibility to do offline configuration. In addition, mechanisms for the connection establishment are being specified. On top of these base models and base concepts, then different device models are being specified for the various device types and application areas. So for example, covering motion, process instruments, remote IOs, and also functional safety, which is what we call OPC UA safety. Furthermore, existing or future device companion specifications can be integrated. So for example, the companion specifications that are being developed by the VDMA, what we will hear in a separate presentation, can be integrated, or other companion specifications out of process industry, for example, PADIM or MDIS. When we look down to the network layers, we find there the different options for transporting data. So this is about using Ethernet or Ethernet TSN, covering also the advanced physical layer or single pair Ethernet, as well as conventional shielded twisted pair cabling. And here we also find the IEC IEEE 6802 TSN IA profile, which is about using the same TSN features to allow multiple protocols to coexist in a common network infrastructure. The FLC initiative also defines different communication profiles. On the one hand side, a UDP/IP profile, which is a routable protocol, very flexible, but then there is a second communication profile that is optimized for efficiency with a direct layer 2 mapping, which is then used for more demanding applications, for example, high performance motion. And the complete structure is prepared to also cover additional standards such as 5G or, for example, Wi-Fi 6, Wi-Fi 7 in future. Finally, FLC is defining conformance testing to ensure a high level of compatibility and interoperability. In order to speed up certain developments, the OPC Foundation is also cooperating with other non-profit organizations. There is one cooperation with Profibus International that was even started before the Field Level Communications Initiative was launched. This cooperation is about creating a safety solution for OPC UA in order to be able to transmit safety relevant data over the OPC UA transport mechanisms. There is already a specification available for this OPC UA safety solution, currently supporting the controller-to-controller use case with client-server services. This is now extended to support also PubSub in the next specification release, and in future these concepts will also be extended to cover the controller to device use case. Another cooperation was set up with the North American ODVA and with the European-based Sarcos International User Organization. In this case, the cooperation is about creating a motion solution for OPC UA based on ZIP motion and the Sarcos drive profiles. With this slide here, I want to explain how the technical solution approach helps in creating concrete device profiles to meet certain features and functions. You see here what we call a toolbox with a collection of all the different facets and options. Now, out of this toolbox, you combine the needed functionalities, the needed options to create a specific device. So in this case, we have been creating a PLC that supports safety and I/O communication, that is supporting controller to controller as well as controller to device. It has all the base models that are mandatory for all the different automation components. And then in this case, the PLC supports both communication profiles, UDP/IP and direct mapping, and supports Ethernet TSN over shielded twisted pair. Second example is about servo drive with functional safety support. In this case, you see here facets for motion and safety. The C2D use cases being covered. Again, the basic models that is common to all the devices. And then in this case, the servo drive is supporting the direct mapping with TSN over single pair Ethernet. And by applying this methodology, you can easily create different variations of products. And certainly there is still the possibility for extensions done by the various vendors, not to take away competition. The roadmap of the FLC initiative is to concentrate in a first specification version on the controller-to-controller use case. So this is what we name specification version 1. And then these concepts are extended to cover in the second specification version also the use cases controller to device as well as device to device. The current status of the specification work is that the initial release candidate has been completed by end of November last year, consisting of 4 parts, part 80 to 83. These RC1 specifications are now being used for prototyping and to also create test specifications and test cases for the OPC-UA certification tool. And certainly these RC1 specifications also are the foundation for enhancements to cover the C2D and D2D use cases in the next step. We have also published a technical paper which is talking about the overall vision, which is explaining the technical approach and educates on the basic concepts for bringing OPC-UA to the field. For those of you that want to dive more into the technical details, we are providing additional material, mainly derived from a webinar we held beginning of December last year. And this material includes recordings of the various presentations, the different slide decks, and also compilation of the Q&A. To summarize my speech, I wanted to explain to you how the OPC Foundation, together with its FLC initiative, is supporting the industrial interoperability from field to cloud and vice versa, and covers all the different requirements out of factory automation as well as process automation, including key technologies such as Ethernet TSN, single pair Ethernet, and the advanced physical layer, as well as in future standards such as 5G, Wi-Fi 6 and Wi-Fi 7. All right, to conclude my presentation, I want to thank you for your attention. And I'm providing my email address in case you want to ask me any specific questions directly. I am also providing some links to the OPC Foundation website and to the landing page of our FLC initiative. Thank you very much.
Hello everybody, my name is Andreas Vath. I am the VDMA's head of Industrial Interoperability, and today I want to give you some information about the VDMA efforts and results for factory automation regarding OPC-UA companion specifications. Before I go into the topic OPC-UA, I want to give you a short introduction about the VDMA. The VDMA is the Mechanical Engineering Industry Association, and we have more than 3,300 member companies. And with this, we are the biggest industrial association in Europe, maybe the world. For that, we are structured in 38 trade associations, and in those trade associations, we have the possibility to represent the needs of the different fields of the mechanical engineering industry. So plastic rubber machines, robotics, woodworking machinery, but also agricultural machinery is part of the VDMA. We have regional subsidiaries in Germany, but also international offices, for example, in Brazil, China, India, Japan, Russia, and also Austria. And what you have to keep in mind is that with this, we are representing the broad machine building and manufacturing industry. So everything I want to give you right now in the next 10 minutes is meant to be used for the whole mechanical engineering industry. And we have the possibility to also harmonize between the different branches because it's all under one umbrella called the VDMA. But let's come to the topic OPCUA. And we need to go one step back because OPCUA is not what we were looking for from the beginning. The need of the mechanical engineering industry are standardized interfaces. So there are a lot of requirements. It has to be on an open platform, security by design, support of different protocols, of course, and important, the semantical machine description. This is what I will tell you more about later. And the benefits are clear. It's a manufacturer independent communication. You can reduce your supported interfaces and protocols and be more efficient, have a better plug and work promise. You can do easier condition monitoring and predictive maintenance. And of course, you can optimize your production. The OPCUA technology was in our research the solution which fit these requirements. OPCUA, Open Platform Communication Unified Architecture, is an open source. It has a security by design approach. It supports various protocols, and it has the semantic machine description, the so-called OPCUA companion specifications. And those companion specifications, of course, don't fall from heaven. They are it's hard work to really develop them and to bring them into the market. And we have a process for that, and we are doing this since about 4 to 5 years. So I think we know what we are doing. And it starts with a preliminary work where we have to get the critical mass of companies behind those developments so that we have the possibility really to spread the companion specifications worldwide and bring it into adoption. Then we have to do the content work, so define which information should be later on in the interface. Then we do the design in OPCUA. There comes the information modeling and the OPCUA companion specification into the play. And then we have the publication, of course, the use in the industry, and we have an international approach. And of course, this is really important. We are looking for a strong consistency between the different specifications. I will give you first an example of the robotic groups, what preliminary work means. They started in February 2017, and about 35 companies were involved. And you can see here, on the one hand, the co-working group members. Those are the members who started the group, who defined the scope. And then we have really a big group, end users, research, component manufacturers, machine builders, robot manufacturers, of course, system integrators, but also IT and software companies were involved. So this is what we mean. We have a strong work in the preliminary work to get the critical mass of companies, of all stakeholders who are relevant to the OPCUA companion specifications into the group. The next step is, and I want to make really a short exercise with you, just some seconds. Please imagine a robot. And now I'm pretty sure that there are a lot of different robot types in your minds. Some of you will have industrial robots, some will have mobile robots, some of them maybe just linear axis, And the question was how to bring all of these different types of robots in one specification, in one interface. And this is what we're doing in our content work. So the group really developed an approach for not only a specific robot, but for so-called motion device systems. And a motion device can be everything which has axis, can turn. Any kind of robot can be described as a motion device. And in the next step, the design in OPC UA, you can see this approach. There are motion device systems. Motion device systems can contain motion devices, of course, controllers and also safety states. And the motion device itself is built up on, for example, axes and powertrains. And a powertrain, of course, is a motor and also a gear. And the axes are also described in the axis type. So starting with this information model, you can rebuild any robot you had in your minds, because if your robot had 4 axes, you can instantiate this axis type 4 times. This was all taken out of the OPC-UA DI specification, which is marked here, and it's all PubSub capable. For publication, we have a homepage, opcua.vdma.org. There you can find all information about the working groups and also the download area for all the specifications. And last but not least, of course, we are working on these specifications to have them used in the industry. And for that, we are doing demonstrator. For example, here, the demonstrator from the robotics, where a lot of robot manufacturers were able to show their capabilities in one dashboard supported by Microsoft Azure Cloud. Right now, I told you about the process to get domain-specific harmonized information models. This all is based on OPC-UA, the technology for mesh communication network, and then we have those working groups who are doing those specifications. And here you can see the different specification working groups, and for example, additive manufacturing or cranes, the foundry machinery, machine tools, machine vision, plastic and rubber machinery, robotics, woodworking machinery. So really the broad manufacturing industry is working here on OPC-UA companion specifications. And in addition to those domain-specific harmonized information models, we need cross-domain harmonized information models. And that means we need the OPC-UA for machinery. And OPC-UA for machinery is a specification which defines building blocks for use cases who are relevant for the whole machinery industry. For example, the identification of machines and components, the topic of domain status, job management, and all the specific companion specifications from the different branches of the machinery industry are using those OPC-UA for machinery as a base for their domain-specific specification work. And with this, we have an in-common basis, and the different domains can then build on this basis their specific needs in their specific interfaces on OPC-UA. Thank you very much for your attention, and if you want to have more information, just visit opcua.vdma.org or please give me a mail. Thank you very much.
Hello, I am Thierry Dano from the Renault Group, and I would like to share with you the subject how to structure and capture industrial data with scalability. A short presentation of my personal background. I have 35 years of experience within the Renault Group in various professions such as maintenance, process engineering, industrial IT, and automation. I work in France in the Renault Techno Centre located in Guyancourt near Versailles. Since 19 2016, I have been working as an expert on automation and robotic technology and architecture. As such, I enlighten the company on the technological choice for the future of our factory. I am also product owner for the industrial data capture project for Renault Group. A quick overview of the Renault Group in the few figures. Renault, it is 5 brands: Renault, Dacia, RSM for Renault, Samsung Motor, Alpine, and Lada. And one alliance with Nissan and Mitsubishi. For the Renault Group on the industrial side, there are 38 production seats and 13 logistics seats in 16 countries. Regarding production volume, we produce more than 3.5 million vehicles and about as many engine, gearbox, and chassis. In 2016, Renault launched numerous digital initiatives in a benchmark factory in Spain. From this experience, in 2017, we launched many digital transformation projects. This project revolved around 5 major pillars: real-time data-driven operation, full track and trace, flexible supply chain and plant, Process 4.0, and connected workforce. The subject that I will detail in my presentation lays the foundation for several transversal subjects. Regarding the subject of industrial data, over time we have accumulated numerous technical solutions which have partitioned the data by typology. Several examples allow me to illustrate my remark. An example on traceability in powertrain plant, an Atlas Copco system when we have Atlas tightening controller, and for conditional benzene maintenance on robot, we have a specific system per brand. If we talk about automated installation, we have installation from the 18th to today and significant diversity of automation and protocol components. Each of the technical solutions has its own architecture, and when we try to mesh data, it is very complicated. When we look at industrial installation, we have a lot of data from industrial equipment such as PLC, input-output, Boolean, robot, vision system, variable speed drive. If we look at the functional need, we need answer on product traceability, process traceability, measure, state of stock, photo, and video. For end customer, we see that data is of interest to many businesses in the company: quality, energy consumption, maintenance, automation, and manufacturing. To meet these multiple needs, we have defined a standard for data capture, and we have a strong slogan that is spread for the company with a common target: collect once and use many. For the capture of industrial data, there are 2 essential layers: the industrial layer, repository layer, where we have defined the data model and the single publication table. The data acquisition layer, where we collect structured data from different industrial equipment. The condition for success for this digital transformation to succeed: the common data dictionary, the unified information structure, the granularity of the data for a maximum of use case, a worldwide standard, a common automation and IT approach. To meet this condition, we have chosen the OPCUA technology with the approach of data model. This element will make it possible to meet the challenge of the factory of the future, where we have unified data capture, interoperability, machine-to-machine communication, edge, cloud, and big data, machine learning, artificial intelligence, and digital twin. Here is a quick overview of the architecture implemented with 3 levels. A first level at machine level, where we have implemented a software brick called UDC for Unified Data Collector. This software transforms all proprietary protocol into OPCUA with a structured data model. A second level at the factory level, where we have implemented a software brick called DFA for Data Flow Aggregator, where we aggregate factory data to send them to the internal cloud until mid of 2020 and Google Cloud Platform since that date. Some interesting data on the capture of industrial data. 3,300 devices deployed in OPC UR, 300 billion data collected since the start of the project, data from 17 factories representing a flow of 10,000 messages per second. We use OPC UR technology for Industry 4.0. From Industry 4.0, we have more than 1 million measuring points. We collect different forms of data, Boolean, string, analog value, table, file, and image. The organization we have to implement all the fundamentals of the data capture project are a team dedicated to the data model made up of multidisciplinary group from OT, ISIT, and process engineering, which has already made 40 data models for the powertrain plant, 10 data models for the vehicle plant, with a target on the creation of 200 data models. A team dedicated to software development with 4 fundamental building bricks: Magic Door plus add-on for data model, UDC for industrial equipment, DFA for aggregation, and Google Cloud Platform for the publication table. The target rate is to be plug and work. A deployment teams made up of factory and corporate automation engineers to implement in the UDC in industrial facility. We first deployed 100-piece equipment in 2018, 900 in 2019, and 2,000 in 2020. The current target is to deploy on a large scale. An OT and ISIT monitoring team to monitor the performance of the complete flow. We have added additional information in the data feed to qualify the end-to-end performance, and we have a real-time dashboard to see all the events. The target is to have an incident rate below 0.5%. I propose a small demonstration that we install and run. A rapid overview what we have in our plant. You see on the screen the central DFA supervision, where we have the complete view of what data we collect in different plants. The first information you see here is the number of value collected per second, and we have more than 10,000 value per second collected. We have here a second value about the number of subscription. We have here more than 1 million of point of measure collected, and we have here more than 700 OPC UR server implemented in all plant. And here you have for each plant the view of the collected data and the volume of collected data per second. And if we click in, we don't have time, but if we click, we can have the view of each plant, how many server, OPC UR server and equipment connected in each plant. The second screen I would like to show you is the number of equipment connected in all plants where we collect data. We can see we have made a ranking of connected factory, and each color corresponds at each data model, specific data model. And we can see here in the most connected plant we have robot, motion device system, we have tightening controller, we have PLC, and we have another manual tightening motion device, function controller for welding point, an energy controller where we collect information about consumption of power, of electricity in each installation. With all this information, we implement in different factory many data model we have decided. And the last dashboard is the number of data we collected in all plants, and you will see we have 17 plants where we collect data. We have approximately 700 OPC US server, and here we have approximately more than 3,000 equipment connected in this. And we have typology of data, file transfer and value, and the volume increased since 2 years with a very huge volume collected. At the end of 2019, we launched a program called Industry Data Management 4.0 to have a unique approach for the company on industrial data. At the data industry referential level, we contextualize the data to create digital avatar of vehicle process operation. At the data operation level, we develop all the use cases requested by factory. The ambition is to break down silo for manufacturing and the supply chain and improve performance. Google, with Google Cloud Platform, bring us their know-how on big data. Because we have contextualized the data, it's easy to develop use case with the unified data. An example on robotic area in body shop and from the data we have developed 3 use cases. The first concerns the monitoring of robot and roller table cycle time to identify workshop bottleneck. It is based on the data from the PLC. This use case is deployed in 10 factories and has generated significant saving in 6 factories. The second concerns the detection of sticky point on welding gun and rely on the collection of torques and position information from robot and vehicle information from the PLC. The third concerns the monitoring of parameter where the welding controller we seek to identify the drift of physical quantity to anticipate breakdown on welding gun. This made it possible to reduce the maintenance workforce. This is no longer any need to manually measure the resistance of the welding gun every week. To end this presentation, we would like to present our vision of the world of industrial data. Our dream is to implement OPCUA from machine to cloud. As the data is structured in the machine, it can be used by all IT systems from the dashboard, MES, ERP, or the cloud. This will ensure two-way communication, bidirectional communication, without modification and without development. We imagine an ideal world where the data will circulate without modification, only with configuration. For the long term, we believe that car manufacturers should work together to share a unified data model to avoid work at our machine supplier. From structured information, it is conceivable to have a rapid deployment of artificial intelligence and machine learning, and Google will help us to achieve it. In conclusion, we believe interoperability is a key part of the factory of the future. Group Renault have chosen OPCUA technology to achieve this. Thank you very much for your attention.
Hello, ladies and gentlemen. This is Julian Backhaus from BMW. Thanks for joining today's talk about OPCUA at the BMW Group. And I would like to focus on edge computing and OPCUA as a success factor for future manufacturing. Yeah, so as you can imagine, I would really love to talk about cars, but today's talk unfortunately is not about cars. It's about leveraging edge computing and OPCUA for our future production systems. And with having that in mind, first look back in the current situation. As you can see, the mess on the left side, a symbolical picture of our IT production landscape. We have a lot of different hardware for each of the production steps. A lot of suppliers have proprietary standards. The shop floor and its IT systems, of course, they have different stakeholders, for example, for maintenance or quality inspections. And a lot of plants, they create their own solution, and these are not known to the central IT. So our main goals for the future are standardizing the custom solutions and the interfaces to get a better maintainability, and that focuses not only in the IT but also to the shop floor, in that case then using OPC UA. Of course, also data-driven is becoming more important, so the easy data access, for example, for analytics use case is really helpful. But of course, also the global scaling possibilities are big topics, because the overall goal to create a breathable production system, which is possible to scale throughput plus minus 20% at any point, is a big topic we are currently working on. And as I said, I want to talk about edge computing and OPC UA. How do these two connect? So at BMW, we have a cloud-first strategy. But of course, there are use cases for edge or needs that we need some edge computing. First of all, control loops or latency requirements. Second, of course, where we have some spherical devices that we have to directly connect, for example, a camera. And of course, in a lot of use cases, we have a high data volume where we then want to do some pre-processing to reduce the throughput to the cloud. And of course, data privacy, some kind of data should stay inside the plant or the enterprise barriers. And that works quite well together with OPC UA, because with standardization, it's a big benefit to the goals we've seen on the first slide. Also, of course, with the information models and companion specifications, for example, for robots, that helps us a lot. Third topic, of course, the interoperability of the components with using OPC UA, and especially using cloud, public cloud, and edge computing. Security is a bigger topic than before. So with the functionalities OPC UA offers, that's a big help for us leveraging these technologies. So looking at our IT target architecture for 2030, and as you can see by the name, that's something we're currently working on. We're not completely there. You can see in the middle that biggest part of our IT landscape will sit in a public cloud. And on the left-hand side, where you see shop floor logistics IT, in that case, that's on Microsoft Azure. In other cases, for example, for our Cloud Data Hub, that is sitting on AWS. I want to highlight some major things here in the picture. First of all, the integration layer in the middle part, where we're doing some decoupling of services on the IT, but as well as on the shop floor side. Main technologies there is based on Kafka for streaming service, and API gateway for more the REST-based interface side. And two big topics I want to talk today is, for example, the edge platform and edge computing, here highlighted in yellow, and OPC UA is our common standard for equipment connectivity. Of course, we will have some legacy world because we really have long-running equipment, over 20 years or so on the plants. But OPC-UA is definitely the way to go here for the new architecture. Yeah, so focusing first of all on the Edge platform and its capabilities. So a little abstract picture of the one we've seen before, focusing on the Edge device and streaming service. Edge platform consists of three main parts, which is the provisioning service, device and application management, and the Edge Store. And all these three enable the business departments and also IT departments to centrally manage and operate and configure apps like OPC connectivity app to deploy them to the shop floor to an Edge device. What are the main features in a life cycle of such application? And these applications are also used in a self-service manner by our business departments, like, for example, maintenance. They can find, install, and manage their application. They can also operate and roll out them using all these functionalities, and also if they are building up some new application, they also can contribute them to the rest of BMW, share them across plants, across countries, and make them globally available. Main benefits are for us in that case also we focus here on standardization. So all these applications are packed in Docker containers with central IT policies. As I already told, the contribution from different departments is possible. We're focusing on hybrid approach, so that Edge device could be an industrial PC directly sitting at a production line, but it also could be an on-prem data center, so on a higher level. And also with that platform, we are enforcing security functionalities like container checks or device policies. But of course, the most important use case on the Edge is machine connectivity. So not only southbound connectors, for where OPC-UA is our main focus, but of course also data transformations, and then to provide them on northbound to other cloud services or the streaming services in our case. And we're focusing on OPC-UA. I would also like to introduce the main phases of what we've done in the past doing right now. First of all, of course, in the first step, you have to establish OPC-UA as a standard for new equipment. So first of all, then of course that started with some tests and so on in our production sites. And so all new equipment is at least OPC-UA ready, has OPC-UA service on board, and can be integrated in the future into new applications. Then during operation and building of cars, OPC-UA works good together with our Edge functionalities. With OPC-UA as a standard, the central managed rollout and changes in the data access is easy possible. Also from business departments, for example, for failure analysis, the flexible and ad hoc data access is really a key success factor. But of course also for the integration of new IT application, that's a big help. With the common interfaces companion specification, which OPC-UA is providing. But of course also if you have to do some replacement or some modification in your production equipment, you can do that across suppliers if they're all sitting on the same companion specification and OPC-UA standards. Which makes it also really easy to integrate and exchange here. I would like to focus in the next two slides two use cases. Of course, there are a lot of other use cases which are rolled out inside BMW. I would like to highlight two of them. First of all, the dust analysis on the edge in the paint shop that you can see here in the background. In that case, we have the edge device you can see here, which have some connectivity to sensors, but also OPC-UA connectivity to PLCs to get some more information about the whole environment, where we are doing then a particle analysis model directly on the edge and just providing the results to higher IT production systems to ensure quality here in our paint shops. The second one is not the classic data use case, so to say. It's in the field of autonomous transport system, and you can see one of these robots. They are traveling around the plant, and of course there are some cases where there are doors. And in that case, we are also using edge devices with an OPC-UA connector to the PLCs to control these doors, so open closing doors. And also in that case, our ATS fleet service management also sits in the public cloud. So that's really already in the target architecture an application, and that's also already used in our plans. Yeah, we're not only doing that for our own, we are also doing that in a community. That's why we founded, together with the colleagues from Microsoft, the Open Manufacturing Platform. After that, also a lot of other companies joined us, as you can see here on the logos. Currently, we're working in different working groups, for example, reference architecture, semantic data structuring, or autonomous transport system core services. But also on IoT connectivity. And IoT connectivity focus on, of course, some architecture discussion, the sharing of know-how and best practices. But the main focus is it's about developing code together and provide them as open source. And all that is based also on OPC-UA as a common standard there. And if you would like to join, just go to openmanufacturing.org and click there to join us or get some more insights. For example, you can also get our white papers there, and we will happy to get new members there. Yeah, that was my presentation for today. Thank you all for joining. If you have some questions, please get in touch, and have a good day. Bye-bye.
All right, that concludes our presentation. It's time to get the panelists up for question time.
Hi, this is Mark Sengupta. Hopefully Craig will get back online. But if the panelists would expose their video, turn on their video, and we can start a discussion. Okay. I want to thank you folks for speaking and see what we have for questions. We do have a question that came to us that it's a question to Julian regarding the Edge store. It says, and any of the other folks are welcome to chime in. But the question is, what kind of topics do you download to the shop floor level? Asset data models, predictive models, that type of thing. Julian, where's Julian? Oh, he's not on here, is he?
He has not been able to join us, it appears. We had his video, but
Okay.
never got him in person. So
Well, let's go.
We can forward that question along to him.
Does anybody else want to contribute to that, or we can go on to another question? Okay. We have a question here. Says, please identify the standards discussed that are conflicting, competing, or duplicative, and or complementary. So would anybody like to take that one on, start talking about what standards they were, industry standards that they've been using and how they've been working with those?
So I can take a stab at this. So it's a broad question, right? I mean, obviously OPCOA is kind of the interoperability standard. There isn't anything quite out there that matches its capabilities in terms of flexibility. And like we heard from the VDMA also, its extensibility of being able to, you know, create companion specifications for standardizing, not just specification or the schema, but also the data models, the information models. So standardizing on OPCOA information models is where you start getting interoperability, and then you can scale, because I mean, the topic of this conversation is, you know, how do we scale? How do we manage to connect thousands of assets and not just 2 or 3? Most industrial standards that I've come across, you know, work well for a small set of assets that you want to connect. But if you want to connect really thousands and you need that interoperability, OPCOA is really the standard of choice, in my opinion.
Great, thank you. Anyone else?
Maybe I can add a little. Simultaneous, huh? Charlie, you want to go first?
No, you go first. You've got a much more detailed view into TSN and OPC, so go for it.
Yeah, maybe I can just refer a little bit to the one slide you have seen in my presentation that showed that we actually built OPCOA on top of existing industrial standards. So we really try not to invent something new that is already out there. So this is really the challenge in harmonizing all these technologies that are out there, not to reinvent something, but try to reuse existing standards and define those things that are still, let's say, empty boxes. And especially the information models and the semantics, this is actually the key where we try to make advances and progress. No,
Go ahead,
you-
Andres.
I think Charlie was first. Charlie.
Yeah, Charlie.
No,
you have
go ahead. Go
Okay,
ahead.
sorry for that.
I already seen it. So
Okay. The information models was mentioned now 2 times. Maybe just one word from my side to that point. What we are trying to do is really to get the critical mass of companies in our working groups where the different information models, for example, for robotic or plastic rubber machinery are defined. And for that, we are really open to get also more companies in those groups, because we have the approach that we want to develop the information models as standards for the different domains that will be able to get de facto standards worldwide. And this is only possible if the standards are also used and accepted by the most of the companies from the different domains worldwide. So if there are any wishes to participate in some of the groups, just give me a message or visit on opca.vdma.org or connect on LinkedIn. So this is really not a closed job development of those specifications. And this is also where we say it's not like there are competitive actions going on. It's more like there is one group, for example, for the robotics, and in this groups, all the experts who are somehow stakeholders in the later on robotic companion specification are related to should come together and discuss to be, as I said, to develop a standard which is accepted by the different companies worldwide, and that can be the de facto standards because there is the critical mass of companies behind it.
Well, thank you, technology, but my Zoom crashed my computer, so I had to do a complete and full reboot. So my apologies in advance. So I'm not sure what questions you've been covered. The last thing I saw was the end of the BMW presentation, and that took everything down. But I know one of the questions that I have for certainly for BMW and Renault is how has OPC UA helped you deal with the connectivity to a lot of your legacy products? Because obviously you're dealing with, multiple generations of automation equipment on the factory floor. Some of the equipment may have been connected with, let's say, older versions of OPC, like OPC DA, for example, in its day. But how have you had to address kind of that legacy issue of kind of going back and being able to bring everything up to speed? And I'll start with, I can certainly start with the Renault. Let me see.
Thierry, you're on mute if you're trying to speak.
Yes.
It's better?
Yep.
Yeah.
You hear me?
Can hear you, yes.
Yeah. Okay, I try to answer the different questions about legacy and over.
Yes.
As you know, we have many multiple component and different technology implemented in factory. And the first job when we work on the subject 3 years ago, we start to define what is good for the factory. And the first step is how we can connect the existing machine. And the first step is very, very important, because when you choose a technology like OPC UA, you have some question like how many times we have the good number of installation with OPC UA. And if you choose to implement this in the new equipment, it's not the good challenge. And you must work to define in the first step how we can connect the existing machine, and after how we deploy it with the scalability needed for Industry 4.0. It's why in Renault we work together. There are some guys who can help me to answer this, because they work on data model. We have some specific people work on data model, and the first step for existing machine, we transform data, the existing data to OPC UA, and we prepare the future of the factory. And when the new equipment arrive with OPC UA natively, it's the same approach, and we can use the same data model. And it's very, very important to prepare the future for the future. For the legacy system, the other question, it's more complex because with OPC UA, we choose to standardize the data, and we think for the future it's very, very important. But for legacy system, old system, and ISIT system with a different technology, the subject is more complex. We have some approach. We have different example where we try to use the OPC UA, but it's more complex than the equipment and than machine because the possibility we have to expose data with a data model, we must develop some specific brick, some software brick to do the job. For example, I have the example about SQL base, and with that, we at this moment we have a specific connector to attack SQL base and to expose in with a data model all the data, and the job is very important, and we can start to transform the data to have a comprehensive data for all.
Mm-hmm. Oh, very good. Now, from your perspective, Peter, do you feel, based on Thierry's answer, is that something that, how are you helping, let's say, as OPC UA, as you continue to evolve your specification and certainly evolve your deployment with customers, whether it be throughout the automotive industry or other industries, how are you affecting that, the same whole issue with legacy?
The approach of exactly the initiative I was talking about, the field level communications initiative, is actually driving the harmonization with OPC UA to areas where we typically today have all the different field buses and real-time Ethernet network technologies. And they're not only using different protocols, but also different semantics. So we are helping actually to bring harmonization, first of all, between the controllers, but then in a second step, even down to all the different devices. So that makes available much more information where you can create your added value upon.
Mm-hmm. Yeah, absolutely. One of the other questions that has certainly come up, and I'll probably ask this more to Eric and Charles, is when it comes to things like, certainly when it comes to the cloud, one of the things that is, in the edge, everybody's always trying to find the line between, what we want to keep local, what we have to worry about, as far as from latency perspective. So what has to be done locally and then what has to be done in the cloud. Where do you see that line? Certainly you're coming at it from a cloud provider perspective, but where do you see, for example, where the edge works best versus the cloud? I mean, it seems like everybody has kind of like their own idea as far as what we want to keep local and what we want to share with the cloud. I'll start with Eric.
Sure. So, I mean, in my perspective, you should keep anything that is production critical on the edge, right? That includes your MES. You can also, if you have a real-time feedback loop that requires real-time networks, like what we heard about, OPC UA over on the field level communication side using TSN technology, that all needs to be on the edge. Once you start doing analytics, especially using machine learning, that is much cheaper to achieve in the cloud, and it's not time critical. So you can upload that. Sometimes you do batching on the edge, or you pre-analysis, so you reduce your payload size, do your analytics in the cloud, and then send the results back down. But anything that is absolutely critical to your production, if your production stops because you lose your cloud connection, that's a bad thing, right? So don't do that.
Right. How about you, Charlie?
Yeah, look, that's Eric has nailed it. I mean, anything that's a time critical loop or anything that's process sensitive, you got to keep that inside the walls of the factory. I think when if you're doing analytics, absolutely that can get pushed up to the cloud. Maybe in the future there's a model where you can get some type of hybrid cloud model where basically you can look at maybe pushing some of this technology a little bit closer, but I think we're a little bit away from that. But yeah, I mean, it's high risk. You're dealing with the laws of physics, right? I mean, it comes down to distance and and how far you can push that data and the return loop. So that's really down to the laws of physics. But I think with TSN and OPC UA, you can probably start thinking about extending to a hybrid cloud model for some of these time sensitive loops.
Yeah. Now, Andreas, when you sort of from the VMA perspective, do you kind of agree certainly with Eric and Charlie's guidelines as far as how as you're working with your members as far as setting the expectation between what's done at the device level versus, let's say, what should be done with the cloud?
Yeah, well, for a lot of companies from the mechanical engineering field, this is also a question where they are figuring out where is the value of the data. And what we see really often is that on the edge level, there is the data which has to be solved fastly, where there's more like raw data. And from this point into the clouds is often not only data, but also information. So there was already some whatever interpretation or value screening or whatever. And in the cloud, there's also those information which have to be processed further on. And in the edge, there's almost all the data. So I agree to both of them.
Okay, good. One of the other things, one of the challenges we have within the factories, I'm sure Terry can certainly bring this point up as well, is the whole issue of culture, is the fact of just getting people to adapt to and willingness to accept change, and whether it be change in the deployment of technology, standards, work processes. So I guess from Renault's perspective, how have you had to deal with a culture issue? We certainly spend a lot of time talking about technology and standards, but if people aren't willing to cooperate and adopt those standards and technology, it becomes certainly a greater challenge to become successful. How have you dealt with that at Renault? And then I'll certainly ask the rest of the panel as far as their perspective on the whole issue of culture. So we'll start with Terry Deneau and then work our way around.
Yes. The culture is very, very important. We start with a small team, and we discover the technology because it's very important to understand what we can do with technology. And after we develop ISIT and OT, we develop a complete solution where the OPC-UA was not view. The complexity is not accessible for all guys. They just see the result, and the PLC engineer work to give a data for the other. We work very closely, ISIT and OT, to do this job, and we work very closely with the plant to implement this approach. And what is the complexity of that? The culture. We have some specific learning about this understanding. It's very important to understand how we work, and with that we develop. It's very important to understand because we have many levels. As you understand, when I present, we have a level of data model. Data model is a work of specialists. There are 3 people work on that. They define the dictionaries, they define how we structure data, and they define how we implement this in machine. And for do the job, we need to have some process specialists, and they give their know-how about the technology, about how it's very interesting to to catch data. It's very interesting to do this job. And this is the small team of specialists who work to define exactly how we structure. There are no other people in this team, because we don't have the maturity to give the job at many people. It's very important to have a small team to do the job and define for the corporate all the structuration of data with the skill of the people in factory and from process engineering. And with that, we have spread an approach with all plants. And at this moment, we start to push data on the cloud. I understand the precedent question, and we are ready to use data at the machine level for edge, at the plant level for MES or historian and other, and in the cloud. And what we choose this solution, we have in mind. In the future, we can start to give sense to the data in the cloud, because it's the first step we imagine. And tomorrow we can push the algorithm at the intermediate level or in the edge, and we can use the same data, the same software, not dependent of the position in the different level.
Okay. I guess, oh, go ahead.
Laurent Corta speaking. I'm the counterpart of Thierry Dano inside Renault teams for IS. And what we built was to provide the same data at the plant as well as the cloud. And we make the choice to not compute the data after capturing data. We structure the data directly in OPC model, and it's forbidden to change any value, we don't make a mean or a maximum or something like that. We provide the data at the minimum level, and each data we capture is with 40 or 45 accessory data, timestamp, all necessary data to be computed at the upper level. It was a revolution for IS people, because when we have legacy system, if somebody want to have the part number of a fabrication, he just want a record with the time, part number, and piece number. But we make the choice to use OPCUA modelization at the bottom level, and to provide the data modelization at the minimum granularity, all in the chain. So it was a revolution, because it was a hard job in the beginning to develop IS systems, to recompute the data and to provide added value from this data. But now we have a dedicated teams who provide software to compute this data. And now we can reuse all these components, and it's more and more easy for us to make value with data. We have exactly the same format of data. If it's a camera, if it's a temperature from a room, from a GTC, or if it is a torque from a robot, it is exactly the same data. Okay. So you can compute it with the same software.
Okay, that's great. How I would say now for our for Eric and Charlie, again, how you're dealing with, as you're going into with cloud solutions, how do you deal with the cultural issues, where there's certainly obviously going to be sometimes the resistance to change? We'll start with Eric.
Yeah, so certainly I've had quite a few plant managers being quite skeptical about, the value of connecting his production line to the cloud. But, I find that if you make connectivity really easy, right, and explain why we're standardizing on an open standard, and, make the data normalization. I mean, you have, like you mentioned, many different, proprietary interfaces in a factory, right? So if you, first bring everything together, and all of a sudden all the data is in the same format in OPC way, and then you can, quickly stand up a dashboard. I mean, all cloud vendors have really simple tools that allow you to build dashboards quickly, kind of a drag and drop kind of a interface. And for the first time, they can start comparing different production lines to one another. For the first time, they can calculate OEE when in a flash. And then, within minutes, the feature requests start pouring in. Oh, now can we want to do this? And now we want to do the other thing. And can you add analytics? And, what about predicting this thing? Why do I need to look at my dashboard the whole time? Can I get a computer to do that, lookup for me, and, can I have it on my cell phone? I mean, then it's just super, the floodgates are open, but you need to make that first step, the connectivity, super simple, because otherwise you lose them.
Mm-hmm. How about Charlie?
Yeah, I think the connectivity is absolutely a big challenge, and that's where it's great to have OPC UA. And yeah, I mean, I agree with Eric. There's not much really to add to that, right? I mean, once you get all your data in the one location, then you can start doing really clever things. So I think initially there's the connectivity challenge. There's also the security concern that everybody will raise about moving, your data outside. People have this vision that once it's inside their factory walls and it's in this building, it's secure, right? But I think having that leap of faith that cloud connectivity is absolutely secure. There's been data in the cloud for many years, lots of financial data, etc. So I think once you get, that's a big challenge, I think, that people tend to question as well. But once you get all this data, as Eric said, in one location, I mean, then you really see the massive opportunity that it opens up. And I think now also to take advantage of the latest technologies like AI, ML, that's really where you have to get the data into the cloud. So people are really looking for the economies of scale. I mean, they can't store all this data locally at any type of near value, right? You have to use the scalability of the cloud and the cost savings that come with that. So I think that's another key point as well. I mean, if you want to basically drive the real intelligence at the factory, on the factory levels for quality output, you have to get that huge volumes of data so you can actually start learning and doing those inferences and start driving those really high value decisions. That's very difficult to do and very expensive locally. Inside the walls of a factory in a local data center, you got to use the scalability and the cost savings of the cloud, and then take advantage of a lot of the predefined models that exist for AI and ML. And as Eric said, that low code, no code ability to very quickly build dashboards and get a view into your data and start doing all these correlations. That's where the real magic happens. So it's definitely changing. It's definitely changing.
Yep.
Yeah, I mean, just one more point. I mean, I also think that since COVID-19, the whole should we use the cloud discussions are gone. I mean, I don't see those anymore. It's now, now it can't happen quick enough, right? And, regarding security, I mean, yeah, maybe 5 years ago, there would be questions, is this stuff secure? A lot of the customers that we've onboarded are now saying, I need to use the cloud because it is more secure than what I can come up with, right? So this is definitely changing. Yeah.
Oh, yeah, absolutely. There's probably no greater force in the marketplace that makes changes than a disaster. And I can tell you, companies that had the digital transformation programs on the 3 to 5 year plan went from the 3 to 5 week plan.
Yeah,
they had to, because they couldn't get their workers to the plants, so they needed to work from home. They needed or combine it into knowledge centers, or if they did have workers in the plants, with social spacing. And it completely, projects that were always like we'll deal with it down the road, were dealt with immediately. As if it had anything to do with remote, the ability to do remote monitoring and remote control and increase visibility to the supply chain. And if it gave you that, those were the projects that were getting approved, even when companies really were not sure about their forthcoming sales and their own futures. So
yeah,
all of a sudden, the number one buzzword was operational resilience.
yeah.
And I think one of the things that is critical is to certainly talk about how OPC UA helps companies with operational resilience. And one of the things I would say to Peter is, that's really going to be, I think, a strong key message for OPC UA going forward. And certainly from all your messaging is, what are you doing to address operational resilience? And I think from Andreas's perspective for VDMA, it's the same thing as, how are you helping your members with their operational resilience?
Mm-hmm.
So I think it's something that is a very critical point, going forward. But
Yeah.
but with that, one of the other questions that a lot of times people have is with the newer technology is, and I compare it to what we're going through sometimes as we're moving to these platforms like vFair, is we certainly could not have a forum today without having the platforms like this. At the same time, there's going to be growing pains, because sometimes as you're using the new technology, little hiccups happen, just like no different than what happened to our session today. So my last question across the board is, how do you deal with the fact, as you're working with whether it be at Renault, or whether it be with, certainly as a cloud provider, or certainly as you're working with your members at OPC as well as VDMA, how do you deal with that nervous factor, which is, if I implement something new, I could certainly have a hiccup, no different than what we've had today with vFairs. How do you help address that? Now, I'll start with Terry, Dino, and Laurent, just to see if get their perspective. It's that fear factor of, if something I've been using for 30 years that works, I now deploy something different, a new technology, I'm always taking a little bit of a risk. And how do you deal with that risk factor? So either, so just checking from Renault's perspective, and if, so go ahead.
Yeah, just one indication about the choice of OPC UA. We choose OPC UA because we analyze the market and the majority of the market. And what we discover, all the PLC brands adopt this technology. All the robots work on that. All robot brands like ABB, KUKA, or Fanuc adopt this or work on that. For example, ABB and KUKA are ready in this technology. And when we choose a technology for OT, it's a technology for 10 years, more than 10 years. And it's very important to have the good choice, not choose the last technology we found on the ISIT, on the Geek, on the other. And it's very important to choose the technology that the maximum of brand adopt it and implement it in their component. And it's very important to have in one part the OPC Foundation to work on data model, to work on companion specification, to give the direction, and the other part the supplier of component that give the material, and at the last the end user, where we define what we would like to do for the next 10 years. And it's very important. We choose. We have analyzed what the automaker do near us, and we define, like Audi, I think, like BMW explained before, we define OPC UA is the good technology, not the best, the good technology for the next 10 years.
Excellent.
We know what we can do with OPC UA, and we know what we can not do with OPC UA.
I assume, Peter, that's a great endorsement.
Absolutely.
Absolutely, and I'm sure Andreas, from the VDMA perspective, you probably have a very similar thought process as far as your adoption of OPC UA with your certainly throughout your membership.
Absolutely.
And I'd say from Eric and Charlie's perspective, the same thing is certainly with this world of IT/OT convergence and leveraging the cloud and the kind of the change that brings. I'd say OPC UA probably brings a level of certainty to people on the OT side as they're willing to work with cloud providers like yourself.
Yeah, absolutely. I mean, it's a end-to-end solution that's proven and tested. So it's a great relief, I think, for everybody.
Right.
Right. And I mean, the one thing what vendors keep telling us, and our entire strategy has been around that, is they don't want lock-in, right? And OPCOA, because it's an open standard supported by 800 companies and counting, doesn't give you lock-in, right? I mean, if you want to switch from one vendor to another, you can do that, if you make sure that you demand support for open standards in your solution.
Yes, one cake, the protocol is very important, but the data model is most important for shared data is very important.
Yep, absolutely. Now we just have to find a way, Peter, to see if some of these platform providers like vFIS can use OPC UA, and maybe we'll have a little bit more reliable connections.
Yeah, right.
It would go a long way. Really, I want to thank everybody, certainly on this, all our speakers and panelists. You guys did an amazing job. I appreciate everybody's patience, both from the speakers, panelists, and attendees' perspective today with our some of the vFIS technical issues, but hopefully those will get resolved. And but with that, this is Craig Resnick with the ARC Advisory Group. I want to thank you so much. I look forward to seeing you all again tomorrow morning when we resume our program. We got a lot of great sessions tomorrow as well. But with that, thank you very much. Have a good evening, and again, be healthy and be safe. Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye-bye.
Thank you.
Bye.
Goodbye, everyone. Take care.
Thank you. Bye.